as you can see, what we're going to be doing is multiplying polynomials. Did you learn yesterday what a polynomial is? Okay. More than one term. This is a polynomial. What kind of polynomial is it if it has two parts? This is a binomial, and this one has two parts, so it's a binomial. And one way to multiply a binomial times a binomial is to use a procedure called FOIL. That is not how I teach it. In the past, my students have been much more successful using a box problem instead of FOIL. If you know how to use FOIL, you can use it. Of course, it works. But I will be teaching this using a box problem. So we start out making a box. If it's a binomial times a binomial, I have two boxes that way and two boxes this way. I put the x plus 2 on top and the x plus 3 down the side. Now, another reason that I like a box problem, it keeps everything organized, but it also has a connection to geometry. Because to find the area of a rectangle, you multiply length times width. So this rectangle right here has this length and this width, and so x times x is x squared. This rectangle has a length of x and a width of 2. 2 times x is 2x. This rectangle has a length of 3 and a width of x, so 3 times x is 3x. And 3 times 2 is 6. So we have multiplied everything together. Now we need to combine like terms. So these terms right there are the like terms. Why are they like terms, I ask? X to the first power. If the power is not written, the power is power of 1. And so x squared doesn't have any other like terms. When you add those two together, you get 5x, and then you also have a 6. This answer has 3 parts. What do you call a polynomial that has 3 parts? A trinomial. Okay, and so then this one right here, again, what? Yes, I'm going to do the box problem. I prefer the box problem. It keeps everything organized, and it ties into geometry. The length times the width, when you multiply those two together, you get 2x. When you multiply those two together, you get negative 6x. These two multiplied together, negative 2x. Negative times negative makes a positive 6x. And then you combine like terms. These two terms are alike because they both have x. Oops, somebody didn't catch my mistake. Where's my mistake? I think I said it, but I didn't write it down. When you multiply those two together, it makes an x squared, because when I looked down at it, I was thinking, well, that would make 3 like terms, but that's because I wrote it down wrong. This should be an x squared. So this is 2x squared. When you combine like terms and you combine it, add a negative 2 plus another negative 2, they have the same sign, you add them up and you keep the same sign. And then we have the 6 at the end. So, one more time. In order to multiply a binomial times a binomial, I use a box problem 95% of the time. The 3x minus 4 goes on top. The 2x plus 5 goes down on the side. You multiply these two together. 3 times 2 is 6x squared. 2 times 4 is 8x, because that one has an x. And positive times a negative makes this one a negative. 5 times 3 is 15x. 5 times 4 is 20. Positive times a negative makes this a negative 20. These are like terms, but the 15 is positive and the 8 is negative. When you combine a positive and a negative, you subtract them. 15 subtract 8 is 7. And then you take the sign of the larger one. 15 is positive, and so this one will be positive. And then I have a minus 20. Now, just to show you the difference on this next example, I am going to use FOIL. FOIL is an acronym. The F stands for the first times the first. X times X is X squared. The O stands for the outer term, X times a negative 5. I stands for the inner term, so that's a 9x. L stands for this last number times that last number, and that would be a negative 45 when you multiply 9 times a negative 5. Just like on the box problem, you have to combine like terms. But often, students get confused with all these lines going all over the place about what they're supposed to multiply to each other. And so my students in the past have been much more successful using a box problem, but if you know how to do FOIL, that's perfectly okay. And if you do the FOIL right, do you see the little happy face right here? There's the guy's ears and his eyebrows and his chin and his mouth. Do you see the happy face? Makes you happy if you do it right. So, next problem. Is this one a binomial times a binomial? It is not. What is this? What kind of polynomial is this one? It just has one term. It is a monomial. This one right here has 3 terms. So it's a trinomial. You can just distribute, but I am going to show you that you can use a box problem for this one too. That's why I like box problems, because they can help you with every kind of polynomial. And FOIL is just for a binomial times a binomial. Now, we have not yet done exponent rules. So just to help you remember, what I am multiplying here is, on this first term, I'm multiplying a 3x times an x squared. What does x squared mean? Doesn't x squared mean x times x? So how many x's do I have multiplied together? So that's how you get 3x to the third power when you multiply those together. When I multiply this one times 3x, negative 2 times 3 is negative 6. X times another x is x squared, and then there's also a y. 4 times 3 is 12, and then there's a times x and times the z. It is traditional when you have more than one variable to put them in alphabetical order. So this is going to be 3x to the third power minus 6x squared y plus 12x z, because there were no like terms to combine. Exactly the same thing you would have gotten if you just distributed. That is also perfectly okay. On the next problem. What kind of problem is the next problem? How do you multiply 3 binomials together? Well, don't try to do it all at one time. You need to multiply 2 of your binomials together and get an answer, and then multiply it by a third. The order doesn't matter. It might be easier to multiply these 2 together first, but these 2 are written down first, so I'm going to multiply those together first. So there's my first binomial. Here is my second binomial. Multiply these 2 together. 2x times another x is 2x squared. 6 times x. 5 times 2. Since the 5 is negative, this will be a negative 10x. 5 times 6 is 30. Positive times negative is a negative. Now, this is not going to go into my answer blank. This is not the answer. These 2 have different signs, so you subtract them, and you use the sign with the larger number. This is the answer for the first 2 multiplied together. But what else do we have? We still have this term right here, so we need another box, because we're going to make another multiplication. Once again, this is why the box problem is good, is because I can multiply a binomial times a trinomial. X times 2x squared is going to just raise that to another power. When I multiply x times negative 4x, that's going to be the same thing except raised to another power. X times negative 30. Then I have to multiply the 7 times the 2 and the 7 times the 4. Since the 4 is negative, that will be a negative 28. Now, 7 times 30 might be a little hard, but 7 times 3 is 21, and then there's an extra 0. And this is positive times negative is a negative. These are like terms, and these are like terms. 2x to the third power doesn't have a like term. When you combine these 2, they have different signs, so you subtract them and get a 10. And this one is the bigger number, so it's positive. These have the same sign, so you just add them up and keep the same sign. So when you have 3 terms, you multiply the first 2 and get an answer. Then you take that answer and multiply it by the last binomial. For the next one, first of all, do you know what a cube is? What's a cube? Well, what makes something a cube instead of some other kind of shape? What's a cube made up of? Squares. All of the sides are squares. And so it's not exactly technically correct, but you can think of it as a three-dimensional square. Well, how do you find the volume of a cube? There are other formulas, but this one will work. Length times width times height. That would give you the volume. So what is the length? What it means when it says that the edge is this much, it means this is the length, and it's also the width, and it's also the height. Please multiply that out and see what you get. How did you do? Did you get the right answer? Do you have any questions? The last example is asking about a volume of a building. On the volume of a building, do you remember that the volume is capital B times H? Do you remember what capital B stands for? Capital B does not stand for base. Capital B stands for the area of the base. And it tells you that this is 3x squared minus 7x plus 2 is the area of the first floor, which would be the base of the building, times the height. Now, we are not going to work that out, but could you set up the box problem to work that out? Okay. Next. I would like you to look at problem number 1 on the homework, because most of the examples that I showed you in the notes were binomials times binomials. Most of the things that we're going to be multiplying out in Unit 3 that we're just now starting will be binomials times a binomial, but that's not what problem number 1 is. What is problem number 1? That one is a monomial times a monomial times another monomial. Do you see any adding and subtracting signs in there in problem number 1? It's not distributing. It's not a box problem. It is just multiply them together. Now, since we have not yet done our multiplication, our exponent rules, let me remind you that m squared, that's what an m squared means, right? And so that is the expanded version of 6m squared n. What does n squared mean? N times another n, right? And up here in the front we have 3mn. So the first thing you're going to do is you're going to multiply your whole numbers together. 3 times 6 is 18. 18 times 2, do you know that one? Is 36. Then how many m's do I have? 1, 2, 3. That's m to the third power. How many n's do I have multiplied together? 1, 2, 3, 4. So that is how you multiply a monomial times a monomial. That's what you're going to be doing in problems 2 and 3. But what am I going to need for problem number 4? A box. Please notice also down here in the instructions it says multiply using FOIL or add this. Multiply using FOIL or a box problem. I don't care which one you use. I just want you to multiply it correctly. This worksheet 3.2 will be due on Monday.